Hey everyone, how's it going? Rosendo from MLH here once again. Welcome to day 4 of Global Hack Week. Let us know. Yes, right on time. I appreciate that. I am a very timely person here. I appreciate you, Zamandu. Zamun Dake. And yeah, I appreciate y'all for joining us today. We've got a great workshop in store for you. We've got an engineer from Solana that's going to come on board. Her name is Brianna, and she's going to be showing us how to utilize smart contracts on the web. On the blockchain and utilizing other Web3 platforms. So it's going to be something that is pretty useful for all of the challenges that you've been completing throughout the week. So if you've had any questions around what smart contracts are, or you're hearing a lot of like jargon throughout the week that maybe you feel like you're not entirely aware of in terms of like definitions or just what they are, this is definitely going to be a great workshop for you to attend and to just stay tuned into, because we are going to give you a really solid intro into what smart contracts are. Yeah, let us know where you're joining us from today as well. Make sure you ask your questions because they will be answered throughout the workshop. And yeah, like keep it locked in here because it's going to be some pretty awesome content that's coming up. And without any further ado, I'll go ahead and bring Brianna on stage. Please give them a warm round of applause.
Hey everyone. Great to be having this workshop with you today. Today we're going to be talking about smart contracts. I'm a developer at the Solana Foundation, so contributing to the Solana blockchain and applications that are built on top of it. So let's get started with the presentation. All right. So we're just going to go over the concept of smart contracts, what blockchain technology is at a high level, the benefits and limitations, some real world applications, and then the steps needed to create and deploy a smart contract. Cool. So we're just going to go over at a high level of what smart contracts are. The whole idea behind a smart contract is that it's self-executing. So it takes away the need to trust a third party in any type of contractual agreement. So it automates a transaction. It's all deployed on a blockchain, which is publicly queryable by any party. And all of the contract logic exists in the smart contract. So it's able to have a very clear point of when a transaction is going to occur and what logic is going to take place when that transaction occurs. So a little history. This idea was actually proposed back in 1994. So it's been around for quite a long time. The technology itself and the tech stack to be able to interact with blockchains and build very efficient smart contracts is relatively new technology. But the idea of having this like trustless system of escrows and removing a third party needed has been around for a long time. And now we're finally able to have like the tech stack available to be able to bring this idea to life. So kind of the components of a blockchain, the components of a smart contract, you just have these embedded terms inside the smart contract itself. So whenever you're designing smart contract logic, you always want to think like, okay, when this instruction is executed on chain, we want X, Y, and Z to take place. And this is all like public knowledge and can be queried on a blockchain by anyone. So all of the data is public, nothing's private, and then you're able to ensure decentralization because it's running on a blockchain, which takes place by having multiple validators being able to come to consensus to create new blocks on a blockchain. So yeah, when you come to consensus, all the validators agree on a transaction. And when that happens, the transaction is then posted as a new block on the blockchain. And once that block is posted, anyone can go in and query the current state at a specific block height on the chain and retrieve that data that's needed. Okay, looks like we have a question. Where is my mouse? Okay. Will we get access to the slides? Yes, I can make those public. I'll share a link at the end of this presentation. Okay. Up next. So we're just going to talk about smart contracts versus traditional contracts. A lot of the way contracts work in, the current state of Web 2 technology is there's always a third party that is needed to execute a contract. If I want to ensure that I'm trading €5 for that equivalent in dollars between someone else, I'll go to an exchange and I have someone who is actually manually exchanging those dollars. If I have a smart contract, I know that I don't have to trust a third party. This logic is already written in code within the smart contract and it's automated, and I can just submit an instruction, execute that instruction on chain, and then it's completely trustless. You're removing that need for a third party. And because every transaction is executed on the blockchain, like we spoke about earlier, it's all publicly queryable. So everything is completely transparent, and it also is quick. Whenever you execute a transaction, it's immediately goes to the validator for consensus, and then a new block is created. Okay. And also cost, since you don't have a third party, the cost is very minimal in comparison to having this like third party person to be able to execute a contract. Okay. So we're going to talk about Solana specifically. There's several different blockchains that exist currently, and interacting with each blockchain comes with a different tech stack. If you work with Ethereum, you're using Solidity to write your smart contracts, and you're working with the Ethereum virtual machine. If you're using Solana, the smart contracts are written a little differently because the underlying programming language is Rust. So everything moving on here is just going to be talking about writing smart contracts within the Solana ecosystem, just to be able to dive a little more granular with creating smart contracts. So on Solana, every smart contract has instructions within it. Instructions are just actions that you want to execute on the chain. You can write as many instructions as you want within a smart contract, and whenever you want to process a specific instruction, you just call that instruction and define the program ID of the smart contract that you deployed on chain. So you're able to define any logic within the instructions. And then these instructions are processing data across accounts. On Solana, pretty much everything is an account. If you have a wallet on chain, that's an account. If you're interacting with a smart contract on chain, the smart contract is also an account. And if you're wanting to be able to hold tokens on chain, that's also an account. So you're able to have these accounts that are essentially just data structures that hold all of the information needed for a specific subset of instructions. And yeah, let's see. Okay. Up next are transactions. So transactions are when you want to execute an instruction. On Solana, you're able to execute a lot of instructions at the same time. So you can bundle several instructions and then execute them all at once in one transaction. So once you do that, you're executing it on the blockchain. So this is that one time when you're interacting from the smart contract to the blockchain and wanting to actually create data that's produced in the next block. So all transactions have to be signed. Sorry. All transactions have to be signed by the appropriate account that's affiliated. Whenever you're creating a, we have another question. Let's see. Is the data on a blockchain stored multiple times by each full node that is part of the network? Do let nodes only store a portion? That's a great question. So let's see. We haven't really talked about nodes yet in the presentation, so let me just give a quick overview of what that is. So full nodes are just, let's see, how do we explain that? Full nodes are basically a complete copy of the blockchain, and you're able to have this redundancy in the network against like data loss, Each node is able to like independently verify all transactions. So full nodes are supported by the network for validating incoming transactions and blocks and being able to query historical data. Light nodes are partial data. So yes, like that is correct. They do not store the entire blockchain state. It's just kind of like a simplified version. Some use cases for that is just to have like specific environments where you only need a small set of information, and it allows you to run that environment a lot faster. Okay, so moving on to, I think we covered everything with transactions. Another thing to mention with transactions, anytime you execute a transaction on chain, you are going to need to pay a fee. That fee is just a gas fee. It's going for Solana. It's going to be in the native currency, which is Sol. Typically, on most blockchains, you're paying your gas fee in the native currency. Okay. And then let's go to the next one. Okay. So whenever you're writing programs on Solana, there's two methods that you can go about it that are very common. So Anchor, if you're actually interested in just like some quick development, you can use Anchor. It's a framework designed for Solana development. Everything is written in Rust for Solana programs. Anchor is still written in Rust, but it simplifies a lot of things for you. So it's a way to abstract away the need for a lot of the low-level complexity in writing smart contracts, like defining specific entry points or the processor, which we'll get into all of that in a few more slides. But it basically has these macros that make it a lot more simple when you're creating smart contracts. So that's Anchor. It's definitely something that I would recommend if you're like looking to get started. Check out that Anchorling textbook. You can just Google it. It's the first thing that comes up. And that goes through pretty high detail of everything you'll need to know for implementing the Anchor framework on writing contracts. The next way to write, also, I'm going to keep referencing them as programs. On Solana, we do consider smart contracts as programs. It's a weird terminology, and I think we're going to go back to calling them smart contracts. But I don't know. It's just a habit now that I say programs. So if I'm saying programs, it's synonymous for smart contracts. But another like more higher level to write Solana programs is with native Rust. The difference here between Anchor and native Rust is just that you have to manually write all of your entry points, processors, instructions, and manually deserialize and serialize accounts. When you're doing that, it just gives you more flexibility to optimize programs, add in additional error handling, things like that, where an Anchor is already predefined within the macros. So you don't have that ability for customizability. However, Anchor is a lot simpler, and 90% of the programs that you want to write will be able to be covered with Anchor. So I definitely recommend like using that framework if you're looking to get started. Okay. So here's the basic structure of what a smart contract would look like on Solana. You have an entry point, and the entry point is the starting point of the program. And that's what Solana calls to be able to access all of the information within the program itself. You have your processor, and that handles all of the information for different instructions. So it's just a way to list all of the instructions that are associated with a specific program, and you'll just be able to pick which instruction you want to access by passing through an array of like U8 type numbers. And then with the instructions, that's all of the actual logic that you want to perform. So we talked about instructions before. Instructions are all kind of bundled within this processor because Solana has a single entry point for all of their programs. So the processor is able to enable a single entry point. So actually, one reason Solana does this, it's because all of their code serializes to binary, and it enables the chain to be very fast, very efficient for running data. Which, if you look at chains, one of the things that Solana is well known for is being fast and cheap. And that's enabled by being able to deserialize all of our data down to binary. So you can see here, that's why we have a single entry point. We have a processor to be able to handle the logic for all the instructions. Then once you go into the instructions, that's where you actually define what you need to do. We'll actually walk through an example to make that a little more clear. And then accounts, which we talked about earlier, is just where all of the data is stored and manipulated. So you have different data structures, and all of the corresponding information is held in accounts. And then you just have to make sure that you implement proper error handling. One thing with this, since it is all automated, you want to make sure that there's no possibility for attacks or reentrancy issues or something failing and someone losing funds and not being able to recoup it. So yeah, that's the basic structure. If you're looking into designing a smart contract, you're going to have to go through all of these steps. And now one thing to know, if you do implement Anchor, the first two steps, you're defining your entry point and your processor, is all handled underneath the backend with the Anchor macro. So you actually don't have to worry about that until you get into writing native Rust. But it's really good to understand kind of how the smart contract is able to wrap up all the data, have a single entry point, and interact with the blockchain. Okay. So here's an example of defining your entry point. All you're using is the basic entry point in the Rust macro, native within Rust, and you want to define this process instruction function. So all this is doing is taking in the program ID, which is your public key of the program once it's deployed on chain, any accounts that are affiliated with it, and then the instruction data. So it's this UA array, which is essentially you're mapping each instruction to a value, so it knows what to call in like a Rust match statement. So if anyone here has worked with Rust, a very common way to write a lot of programs within Rust is using a match statement. If you're not familiar with Rust, just a high-level overview, Rust is a type-safe language. It is memory safe. All variables are immutable by default. So it has a lot of interesting things with the language that's all incorporated within smart contracts as well, because we're coding them all in Rust. Okay, so once you define your entry point, you then want to be able to match all the instruction data. So here in this code, we're just giving an example of a very simple counter function. So you can see like how all of the instructions and logic is mapped to the instructions. So here you can see you just have increment and decrement and then an error. In a match statement, you're able to have each value associated with the corresponding logic. So if a 0 is passed through the instruction data array, it will then call the increment counter function. If a 1 is passed through the instruction data array, it'll call a decrement counter instruction. And then if anything else is passed through whatsoever, it will then return this error. So that's just a simple match instruction within Rust. And that's what's used anytime you want to process all of your instructions for a Solana program. Okay, so now that we have this, we have our entry point mapped out, we have our processor mapped out, then we want to be able to actually write the logic. So we'll just go through here. This is an example of the increment counter. This is your instruction handler. So within each instruction, you have corresponding logic. So here's the increment counter that would be called if someone passes 0 through the process instruction. And all you're doing here is just passing through the associated accounts, the program ID, which is the public key of the program deployed on the smart contract. You have some error handling in here to just ensure that the right person is calling the instruction. and then you're updating the value. You're specifying that the variable is mutable because you're wanting to change data, and all variables within Rust are immutable by default. So yeah, that's just how we process instructions. And then just error handling, you're able to use native errors within Rust, or you can use a crate from Solana that implements basic program errors for smart contracts on a blockchain. Okay, so now we went over how to write a smart contract. Now, once you have a smart contract written, just writing it doesn't actually enable you to interact with the blockchain. So to be able to do, you have to deploy onto a blockchain. So the smart contract has a chain to interact with. So there's a lot of different ways that you can do that. Here you have different clusters for Solana. You have a mainnet, a testnet, and a devnet. So these clusters are your nodes that work together as part of the blockchain. And mainnet is where anything with real assets take place. Testnet is just used with fake assets, fake programs, just kind of emulated in this environment to be able to test things out. DevNet pretty much does the same thing. So whenever you're working with a program, your steps are to deploy to testnet or devnet to be able to test it out. Make sure that interactions are how you expect. Do a lot of different like QA with a lot of different scenarios. And then once all of that passes, it works, you're able to deploy to mainnet, and then anyone can interact with their real wallet and real assets. So that's what a cluster is. Once you have the cluster, you want to be able to deploy to it, interact with it, and all of that is done with endpoints. So endpoints are just a way to interact with the Solana clusters. If you want to deploy through your computer, you're going to specify a URL of an endpoint that allows you to interact with the cluster. So Solana actually provides public APIs that you can access as endpoints to be able to interact with the blockchains that they're running. Yeah. So once you have that, you deploy. Once you know about the clusters and the endpoints, you're able to deploy. When you deploy, you want to compile your code. So if you're familiar with Rust, typically you want to cargo build, and that compiles your Rust code. However, Solana uses the Berkeley packet filter to interact with their runtime environment. So whenever you want to compile your code for Solana, you're going to use cargo build with the BPF flag. So it compiles down to the Berkeley packet filter bytecode. And then once you have that compiled, you're able to deploy. You can deploy with the basic Solana CLI tool suite. If you have that enabled on your computer, you just run Solana deploy, and it takes your program, deploys it on the chain with the specified, using the specified RPC endpoint, which is just the URL that you use as a flag when you deploy. So that was a lot of information, and we're kind of going to go through an example. So we'll backtrack a little bit and run through an example of just building a basic CRUD app on chain, and it'll just reiterate all of the points that we made. Okay. If you're following along with me here, you're just going to want to make sure that you have Rust installed on your computer, the Solana tool suite installed on your computer. And yeah, that's about it. So if you're setting up a workspace, there are two different ways you can set it up. One is if you're using Anchor, you can initialize with Anchor. So Anchor and Knit will set up a workspace for you with all of the needed Anchor crates. And then there's also this really fun scaffold. It's called NPX Create Solana dApp. And what this does is it connects a background it connects the back end to a front end for you. So it'll have within the scaffold, it'll have your TypeScript code as well as your Rust backend code. And then you're able to create a full application on chain by just using the scaffold here. And if you do run npx create Solana dApp in your CLI, you'll be able to have a counter program running. It like creates the counter for you, creates the front end for you. You can just run the front end on your computer and actually interact with the counter, and it'll make transactions on chain for you. All right. So first, whenever you're writing a smart contract, I always like to think of the storage that I need. So defining the state for a contract. Here for this CRUD app, we're just creating a journal. So within the journal, you're going to be able to create journal entries, read them on chain, update journal entries, and delete journal entries. So first, we need to define the state. Anything you would want for a journal to store is just the owner of the journal, the title of the journal, and the message of the journal. So everything you see in this code is actually part of the anchor macros. So this is simplifying a lot of the code needed in the beginning. You don't have to write the entry point. You don't have to define the processor. All you do is you specify this account macro and you create a data structure of the storage that you want on chain. So one thing to note is that all of smart contracts on Solana are actually stateless. So this state goes with accounts. So anytime you interact with the chain, you want to initialize a new account, and then your account associated with your wallet is going to hold all of the data needed for your interaction with the program. So none of this state is actually saved in the smart contract itself, but it's stored in accounts on chain. So here we just defined everything I want to store, 3 things in my data structure for storage. Now we write our instruction. So if you remember, we talked about how instructions are a way to interact with the blockchain. So within smart contracts, the main purpose of writing a smart contract is having instructions that define logic to interact with the chain. So our first instruction that we want to write is to be able to create a journal entry. So here, all you're doing is just writing an instruction within this macro defined by Anchor. All of these macros you'll be able to reference in the Anchor textbook that was linked earlier for Anchor Link. But very basic structure, all smart contracts follow the same thing. So within this program macro, your program, as we talked about before, was synonymous to smart contracts. So you define your program macro to say, hey, I'm writing these instructions for my smart contracts. So this is going to be where all of your instructions live. So first instruction is just creating a journal entry. And I want to pass through the title and the message of the journal entry that I want to create. Now, this first parameter that you see in the instruction, the CTX, this is actually part of Anchor. So it's called a context. Your context is how Anchor is able to process all of your account information. So that's kind of how this processor is running in the backend that we talked about, that's abstract by Anchor. So yeah, you have your context. Oh, looks like we have some questions. Let's go back to that. Okay, so public key is the public address of a wallet, right? Yes. So a public key is basically, on Solana, it's a little different than in MetaMask, just because it's using like a different cryptographic way to derive the key. So a public key on Solana, it's the ED25519, I believe. Public key type, and it's just a byte of specifically generated values. And then let's see, we have is message also a macro? Yeah. So if you're using message from the Solana program library, which is imported by a crate, that's also a macro just defined by the SPL. Oh, turn that off. sorry. That's a macro just defined by the it's a macro defined by the Solana program language. It's just like a way to debug things. It's kind of like your console log in TypeScript. So yeah. Okay. So let's see. Yeah, so when we create any type of instruction, you always have to pass through this context when you're using Anchor as the first parameter. And it's just a way to handle all of your accounts, handle processing all of the instructions within your smart contract. And then any type of user input values, you pass those parameters after. So here with a journal, the user is going to define what the title and the message of their journal is. So that's all you have to pass through. And then you're able to process a result. So here we used message just kind of, so when you're running the program, you're able to see everything and debug it if you're live coding it. However, it's really not needed. It's really just like your console log essentially. And then you have you're loading in your context of your journal entry account. So in the last step, we defined that our state was a journal entry struct. So we're just loading that state in for a specific account. And we're updating the state. So all this is doing here is loading in your state of the associated account, updating the state to have your title as whatever value that was passed through as a parameter, and for your message as whatever value is passed through as the message parameter. And that's all that's happening here. Now, how to define what this context is, you have to write a data structure for each one. So you can see that the context has a create entry data structure associated with it. So let's write that next. Okay. So here is where you're really processing all of the account information. We're defining the data structure for the create entry instruction, and you're just specifying the associated constraints on the macro that you're using from Anchor. So here you're creating a new account, so you're initializing it. You're defining the PDA. So a PDA is a publicly derived address. It's a way to create this public key. So every public key has like data encrypted inside of it, right? So here you're just specifying how you want to create it. So later you can find it with given data. So I'm just creating a public key with the title and the owner of whoever's creating this journal entry. And then you're going to specify a payer. The reason you need a payer is because whenever you have an account on chain, you need to pay rent for the account. And the rent is based on the size of data that you want to store on chain, which is why you have to then calculate the space after you specify a payer. And the space is just calculated by what data that you need to keep on chain. Okay, looks like we have more questions. Yeah, so this question is, what are some benefits of using Rust for smart contracts instead of a language like Solidity? There's a few things. Rust is, let's see. Personally, for me, Rust is type safe. So I like coding in type safe languages. But it also just helps with performance because Rust is memory safe as well. So Rust has this like ownership model in it where you have like ownership and borrowing rules within variables. So that helps with memory safety. There's also no garbage collector in Rust. So it manages memory without a garbage collector, which helps have less resources needed for blockchain technology. And Rust has a really great concurrency within like natively within the program. So it just like helps being able to manage data how you need to handle it when you're working with blockchain technology. Solidity, I really haven't worked with that much, so I don't have like hands-on experience with it. But if you are working with a different ecosystem that does use Solidity, then you would have to use that language. But Rust was used for Solana specifically just to help with efficiency and having a very like robust coding language. So yeah. All right. So now once we defined that data structure, that's our first instruction is completed to be able to create an journal entry on the chain. Now we're going to write our update instruction. So here you can see this looks, it looks exactly the same because it is. I didn't change the name, but it actually is the same exact functionality. So this would look the same if it said update. But you're just loading in the state of an account and then changing the values. So you're making the variable mutable here. So you have your journal entry is mutable when you load in the account state. And then you're able to update the owner field, the title, and the message field based on parameters that are passed through the instruction. So everything that happens within the instructions in Anchor are pretty simplified. You can see here. A lot of the main manipulation of logic with Anchor happens in your data structure that's being written. Because Anchor macros are processing all of the entry points and account manipulation through the macros, and you don't have to do it manually. So you can see if I define the context for updating an entry, this is where like kind of the meat of the logic is happening. So here you're just passing through, you have your accounts and you're wanting to have these account constraints. So you're making the account mutable because we have an account that already exists on chain and I want to update it. So I have to define that it's mutable since any variable is immutable by default with Rust. I'm specifying the seeds so it's able to find the correct associated public key. And then I'm specifying this reallocate constraint. So what this is doing, it's a constraint within the Anchor macro that's able to reallocate information. So I'm specifying a payer here, and I'm specifying a new space. And the reason that this is needed is because information can change and I can take up a different amount of space on chain. So if my first message was just hello, I'm taking up a very small amount of space on chain. But if my next message was a very long paragraph that I'm updating my account to, I'm taking up a lot more space on chain. So that has to be specified here is how much space is now being taken up with the updated information. And if more space is being taken up, you have to have a payer to be able to pay for that additional rent. And if vice versa, less space is being taken up, you have to have a payer that's going to be able to receive a refund for taking up less space on chain. Okay. And then we have another question here. Oops. Can we use Golang or any other language for writing a smart contract? So it depends on the ecosystem that you're working with. I know that if you want to work with Cosmos, the Cosmos SDK is written completely in Go. You have, I don't know of any other ecosystems off the top of my head that use Go. Just like a high level rundown, like Ethereum uses Solidity. It's also supported by Viper. Solana uses Rust as like the primary language. C is also supported. I think Cosmos is the only one that uses Go. I could be wrong because we're constantly updating capabilities. But with Solana right now, you just have Rust and C. They're working on launching Move, which may incorporate Go. I know it might incorporate Solidity, but all that's kind of in the works right now. So, yeah. Okay. So next is writing your delete instruction. So just to recap, we've created a journal entry. We were able to go back and update information. And the only difference between creating and updating was using a reallocation constraint within the anchor macro. And when you're creating, you're using this initializing constraint because you're creating a new account. So now you're deleting, and you can see that this instruction actually has no logic whatsoever. It just has a console log of the message macro. Nothing else. So as you can tell with Anchor, most of like the meat of the logic with manipulating accounts happens within the data structure of your context. So here you're just running through the context of the delete entry, which we're going to create in the next slide. And the title is needed to be able to find the associated public key. And you're just returning an OK statement. So we'll go to defining the delete entry context. So here it looks pretty much the same. You have a mutable account. You're defining the seeds to be able to find the corresponding public key. And now you're incorporating this close constraint with the anchor macros. So if you pass through a close constraint, you want to specify a specific public key that can execute the instruction. And if that public key is the signer of the instruction on chain, then the account closes. So you can see a lot of the logic is happening within these account constraints. So if you want to really see like the art of the possible with Anchor and building smart contracts on chain, definitely look through the account constraints within the Anchor textbook that we talked about earlier. All right. So once that's done, you just want to build and deploy the program. So you can, if you're using the Anchor framework, you can just run Anchor build. If you don't have the full Anchor workspace set up, then you're using the cargo build BPF that we talked about earlier. Both of these commands compile your Rust code to the Berkeley packet filter. And then once that is built, you just run Anchor deploy. And when you deploy, you just want to specify the cluster that you want to deploy to with the corresponding RPC endpoint. All right. So that's my high-level overview of writing smart contracts. Let's go through any questions that you might have. Okay. So one is Anchor widely used with mainnet apps or something more used with testnet apps? That's a great question. I would say most of the more complex mainnet apps are written in native Rust, but there are quite a few apps written in Anchor still. Anchor provides 90% of the functionality that you need. You really only need to use native Rust if you're focusing on, optimizing a lot of account handling, adding an additional error handling, things like that are very like low level. Otherwise, like mostly you can do everything with Anchor. The only other downside to Anchor is, in comparison to native Rust, is there's an upkeep to it. Anchor does, have new releases, which are great, but then you're going to have to update some of the code within your program to be able to keep up to date with the new releases coming out. So yeah. A next one is, will the basic understanding of Rust is enough, or does one need to be an intermediate to advanced programmer in Rust? So it depends like what applications you want to write. As you can see, we just built a CRUD app, and that is a fully functioning CRUD app. You're able to make multiple journal entries, connect it to a front end, update them, delete them. So that had very little Rust knowledge needed. So all you really need to know there is variables are mutable by default. immutable by default, sorry. And that's really all you needed to know for Rust specifically. If you're starting to write like native Rust programs, that's where like more advanced Rust knowledge is going to be needed. Kind of how memory works, how to optimize ownership and borrowing with different variables. But to be able to be an efficient smart contract programmer on Solana, you can just have a basic understanding of Rust and you'll get along very well. All right. Oh, we have a lot of questions. Oh, wait, no, we don't. Okay. Any more questions? It looks like we covered pretty much everything. All right. Well, if there's no more questions, that's everything. Oh, here's another one. Do we need any money for gas? Yes. So anytime that you want to create a transaction on chain, you do have to pay gas fees. On Solana, gas fees are less than a penny. So it's very much negligible in the grand scheme of things, but you do have to have Sol in your wallet to be able to have an execution, to be able to execute a transaction and have it actually go through on chain. If you're only working with DevNet or testnet, you don't have to have actual funds. So anytime you create a new wallet or public key pair on chain, then you can just airdrop funds to yourself. And it's this like testnet version of Sol. It's not really worth anything, but it's needed to be able to pay for the gas for testnet or DevNet transactions. So that's a way to be able to emulate connecting to a blockchain and creating transactions without actually have to pay for anything, because you have this like fake Sol in your wallet. So yeah. All right. Well, if there's no more questions, that's everything from my end.
Awesome. Oh, sorry. It looks like we have another question here.
Okay. How different are blockchains from each other between Ethereum, Bitcoin, Hyperledger, Solana, Near, etc.? So it's really like the underlying mechanism of how the chain works. So Bitcoin, up until recently, has pretty much been like a store of value. There aren't really apps deployed on the chain. Ethereum works with, it's one of the first chains that allows for like apps to really be deployed and like utility to happen with the chain. So it's very new in technology, which means like it has a higher gas fees. It's a little bit slower than other chains that are built, but it has the most apps built on it. So like you're just kind of like looking at the ecosystem and how it's built. So like Bitcoin and Ethereum, their consensus mechanisms are all proof of work. But Ethereum transitioned over to proof of stake recently. You have Solana uses this like combined consensus mechanism of proof of history and proof of stake. So you just kind of like look at the consensus mechanism behind each chain to understand like the core differences and how they run differently. But they all kind of, have a different purpose, a different consensus mechanism. The smart contracts have different tech stacks. Like we talked about how you need to know different languages. Like if you're comparing the Cosmos ecosystem, they're all app chains. They have different chains are all running with, they're written in Rust, but everything deserializes to JSON, where on Solana, everything's written in Rust, but everything deserializes to binary. So everything on the back end kind of works differently. If you're interacting with the front end, it's very similar. The only thing that you would really see on the front end that's different is your transaction throughput and speed and gas fee cost. Yeah. So one of these questions is that you tried with Ethereum and it needs to be 0.001 ETH in an account for testnet. So Ethereum does have like higher gas fees. It has like other needs because it is running with a different consensus mechanism. So yeah. The next question, does this provide service for Ethereum or Bitcoin? I'm not sure what you mean by service. If you can have like Ethereum and Bitcoin coins on Solana, can I write a Solana program and have it interact directly with the Ethereum and Bitcoin chain? No. So yeah. If you're building a cross-chain application, do you ever build a bridge, or are these already built? Yeah. So bridges are essentially a way to move funds from one native chain to another. So if you're bridging native Ethereum over to Solana, you're going to then end up with this like wrapped Ethereum on Solana. But it's a way to change assets from one ecosystem to another. If you're building a cross-chain application, it depends how you write the underlying logic. I've worked on a few cross-chain applications, and the way that we did it was you have to write a smart contract per chain that you want to interact with, because it does have a different tech stack. It does have underlying mechanisms that are different. So the core logic is going to be slightly different per chain. So we wrote separate contracts, deployed each contract to its respective chain, and then to be able to have funds move across, we just used a bridge that was already built. And you can connect to those through a lot of different like methods. Okay, next question. Why choose Ethereum when Solana is faster and cheaper? Why can't we all switch to Solana? That's a great question. I would say like Ethereum has been around for a long time. There's a lot of applications that are built on there that people are used to using. Personally, myself, I don't use Ethereum anymore just because it is expensive, it is slower, and I just like the UI and UX on Solana. But there are things that are different where Solana works with like a proof of history and proof of stake, and then Ethereum works with a proof of stake. So it's kind of different consensus mechanisms. So the underlying logic is different. So some things that do exist on Ethereum don't exist on Solana today. Solana's a lot newer, but applications are like consistently being built out. Okay, next question. What roadmap or an overview would you suggest for a beginner to get into blockchain or the Web3 ecosystem? So I would say first, like if you're completely new to the Web3 ecosystem, start interacting with different applications. So like for Solana, go like make a wallet, go on to Jupiter. Jupiter's a swap aggregator, swap different tokens, like see kind of how the UX works. See different, you have like Jito as a liquid staking protocol. It's just work with different protocols and dApps that are deployed on chain and just kind of see what it feels like from a UI UX perspective. I think like that's like the biggest thing is just like understanding how the ecosystem works. Once you do that, then start diving into the tech stack. So if you're looking for at Solana specifically, definitely like read through Inker, get like a very high level overview of Rust, start building some quick applications. There's a lot of guides on solana.com/developers. So if you go on solana.com/developers, you'll be able to interact with different guides, tutorials, a few different boot camps. And that really takes you through from like 0 to 100 and shows you like all the steps needed to become a Web3 developer. Okay. Next question. Okay, Solana, Bitcoin, and other crypto are separate from each other, or do they interact with each other? So all of the chains run independently, and all of the smart contracts that are deployed on each chain run independently. If you want to be able to interact with different chains, you'll have to use a bridge to be able to like switch assets between. But all of the applications that you interact with are running on their respective blockchain. Okay, next question. Are there any Oracle services available for Solana smart contracts? Oh, went away. Where'd it go? Oh, okay. Example, I'm looking at using Chainlink to get real world data. From what I found, Chainlink data feeds are available in Solana, but functions allows you to call any API and is only available on Ethereum. Yes. So if you're looking for an Oracle service, Pith is a really good Oracle. Pith is like relatively new. It exists in the Cosmos ecosystem as well as the Solana ecosystem. So it's just like an Oracle that allows you to query like data feeds. Chainlink. So yeah, Chainlink data feeds are also available in Solana. Functions, if I remember correctly, Chainlink functions is like a way to automate I thought it was a way to automate instructions. I'm actually not sure about Chainlink functions. I don't know if there's an equivalent on Solana. But if you're looking for Oracle specifically, there's also, yeah, you have Pith, you have Chainlink data feeds, there's Switchboard and Band Protocol are also Oracles that you could use. All right. And I think that's all of the questions now.
Awesome. Thank you so much, Brianna, for answering all of these questions. Oh, look, we've got one more question here. We probably have time to answer this last question. So definitely thanks for these last couple of questions. So thanks for submitting them. I'll just pop them on screen here for you.
Yep. Awesome. So the last one is, can you describe the role of Web3.js? Web3.js is a way to interact with the blockchain through the JavaScript client. So instead of having to query directly through your CLI with like the Solana CLI tool suite, Web3.js enables you to have these like helper functions natively within JavaScript by using like Web3.js to just directly interact with chain, create wallets, kind of emulate an environment to be for testing. So yeah, it's a way to make Web3 developments very friendly to like JavaScript, TypeScript developers.
Awesome. Well, really appreciate all of the awesome answers that you had today. Thank you so much for your time. It was very, very informative. Specifically for me, I was in the back here doing some research on Solana myself. For the folks that are joining us, definitely check out the rest of the Solana challenges at the link that's scrolling across the bottom of the screen here. If you have any other questions with regards to like, any of the content that you saw today, head over to the Discord channel, to the Ask Solana Discord channel specifically, and yeah, drop your questions there. And also I'll be dropping the link to the slides that were mentioned, that were shown here as well, after Brianna sends them over to me. So no worries there. Just make sure to check us out on Discord and you'll get all the information you need. And yeah, I mean, thanks so much for joining us again, everyone. And thank you again, Brianna. Really appreciate it.
Thank you.
Bye, y'all.